All right, so maybe no need to introduce Ivan, but just for those of you who don't know him, he's the CEO of Codexio, and he'll give a very interesting session on how you can implement design patterns with frameworks like Spring. So, Ivan, you have the word.
Am I audible? Ah, I am. Hey. Thank you for having me. So, since Martin said there is no need for me to be introduced, then I will not introduce myself either. So just go on the first slide. No, just kidding. Let me give you a bit of a context what we're going to talk about today, and after that, if you haven't felt slept after the lunch, probably I will say a bit some words for myself and the company I work in or manage. I don't know how to say. So you know what you have gathered here, probably already struggled with design patterns, either to implement them, to use them, to understand them, or to make your team use them. At least this is my struggle. I don't know if I know them by heart, but I can see that lots of people either do not or do not want to use them. This session is about how to use design patterns in any inversion of control-based framework. So it's Spring as a notable example, but it can be any other framework that inverts the control, calls your methods, and instantiates your classes or your objects. This is a very crucial part of that because it makes fucking hell easily to implement these design patterns. In any other system that's designed by a developer alone from a main method, it's hell hard to implement them. You say, okay, how I need to have these objects stored there, how to pass them there, but I need to pass them there, and then you said, fuck it, I'm not gonna do it. And that's how no design in the code base is born. But you have no excuse if you use Spring Framework, Quarkus, or whatever you want that has inversion of control as a main operation. So what we are going to try is to produce some code quality, or at least try to give you my advice of what should a quality code base at least look like on the foundation. It can be extended a lot more than that, but I have limited time in this planet. Okay, so let's still introduce myself. My name is Ivan Yonkov, and I'm the founder and CEO of the software consulting company called Codexio. We are actually trying to be not that traditional software development company that's just doing the things, you know, controller service, GSP, or some view, JSON, whatever, and that's all. We're actually targeting these partners that want high scalable, low latency solutions where design patterns and languages like anything else than Java make sense. But since the latest versions of Java, it also makes sense to use Java, and we do that for most of our existence. I call myself a Java archaeologist because of the fact that I do like to have a little bit fun with all these old systems that you can find a lot of cryptic things, and people are saying, this legacy, I don't want to use it. I want only the new things. And people that only want to touch new things actually never learn anything or anything useful. So what I would say as an advice, be an archaeologist. Dive deep, see what people and the tribes before you have done, and try to find a way to optimize it, try to find a way to qualify it. That's what made me a better developer than what I were before. How better, I don't know, but better than what it was before. Okay, let's skip the introductory part and see what we are going to talk about. We will try to refactor some code. So it will be a case study presentation. You will see lots of code here and there behind me. And this code we will try gradually to refactor by using some of the most popular design patterns. And I clicked twice. So we will evaluate some different patterns. We will use 2 or 3 patterns in this presentation, but of course I would like you to be engaged into that, and if you have any questions, just raise a hand and propose some solutions. Say, wouldn't it be better with a different pattern? Why do you use this one, Ivan? Are you crazy? Or whatever it is. So we will try to evaluate some solutions and use some of them, implement 2, 3 design patterns in the context of an inversion of control framework. In this case, it will be examples only with Spring Framework, but it should be easily replaceable with whatever other inversion of control framework you want. So these will be the main benefits that we will see, that it's very easily implementable. Not the design pattern itself, but the design pattern put into your code base. Because you can say, okay, there is a factory here, but how do I use this factory in my code base, for instance? Or singleton. Yeah, just a little bit of a context before giving the example. What I mean, but use this inside an inversion of control framework. I have no example for this, so I'll just be talking. Try to follow my speech, if you can, because I speak some nonsense sometimes. So maybe all of you read the Design Patterns book or any other smaller book that is doing the same. And there is this singleton design pattern where you see a private constructor, a static field that holds the only instance, some synchronized blocks, whatever it is, no matter, and a get instance method. And then all across your code base, in order to use the singleton, you say, let's say my database.getInstance.something, my database.getInstance here and there. But if you have been used custom to Spring Framework, you may never seen that, because you have some bean, you annotate it with component, and it becomes a singleton. Wherever you inject it, you have this same instance, right? So you have singletons here and there, here and there, here and there, without implementing this design pattern, and without making this anti-pattern of .getInstance, because dependency inversion, on the other hand, is better than having static calls, right? That's what I mean, that an inversion of control framework will usually make your life easier. But let's jump to our case study, and it will be a very simple airline quotation system. You have some flights here and there from Sofia to Frankfurt to whatever, and then you want a quotation for 5 persons for economy class, and you need to have pricing, right? So to implement this, we will have as a given an entity called flight. And this flight, obviously, it has where it starts, where it departures, where it arrives, at which point of time. So you have the airport and the starting time, and the airport and the arriving time as well. And some set of prices. And these prices will represent the prices for the economy class, for the business class, or for any other class that can be implemented in this airline. You know, you're very accustomed to business and economy, but some airlines may add some more or less than that. So this is something that's highly customizable. And because it's highly customizable, we will have this pricing in another entity called pricing, which has the type, which is another table. It's another table because someone from the admin panel, from the back office, can enter a new one. So we want it to be dynamic, not something hard-coded in our code. And our request that will come from the user will represent only 2 things. Which pricing type, let's say business, and how many persons. 2 people for business, for instance. And you need to query your database, see what is the pricing, and probably add some rules. The problem is that the pricing is not static, right? You have the pricing in the database, but this pricing is for a single person. What if I want to book flight for my whole company? Then probably they should give me a discount, right? Or what if this flight is in some very inconvenient time? Maybe they need to discount it too. Or they need to, if it's very convenient time, probably they can increase the price, right? They do it. Probably discounts are not that very common, but the increase of the price is there. So imagine we need to implement this quote method that's inside some service in Spring, Quarkus, whatever, that has what flight ID I want to take the quotation for, and how many people, business, or whatever class it is. How do we approach that? Well, we need to find the flight from the database, then we need to find the prices and find this price for the certain class, for instance, for the business class. This price info will give us the amount. That's fine, but as I said, this thing is dynamic. We take this amount and tweak it down or up, bottom or upper, depending on some other parameters. And these parameters in a real-life scenario can be millions. For instance, for a business class, we may have whether the hours are starting from some convenient time or not, whether the persons are more than some threshold. It can be certain thresholds as well, not only one threshold. And this can tweak the price. It can discount it or increase it. In this time, it's discounted by some percentage. The same can apply for the first class, for instance. For the first class, there is only two rules here, where it arrives or when it departs, and depending on that, if it's like after 1 a.m., probably it's very inconvenient for you to use it, so we will discount it with around 10%. You can see that we are dividing by 1.1, which is not exactly 10%, but this is how some people are doing. You can imagine if we have a third class, which is called the business class, which is called the economy class, we will have another case in the switch. In this time, for the economy, they don't discount you for any inconvenience, just give you a couple of discounts if you buy for lots of people. If you buy for 10 persons, you receive 20% of discount, or around 20%. If it's for 5 or more people, between 5 and 10, it can be 15%, and if it's less than 5, okay, so screw you, you pay the full price. And on the top of that, imagine the airline adds another rules, which can be how much is the duration. If it's an overseas flight, maybe they will give you some discount as well. Maybe. In reality, they will compensate it with something else, but let's imagine that you will have this discount. So this code base maybe is very familiar to you. Not this particular code base, but the way it was structured. Switch cases here and there, if else's here and there, nested if else's, in another nested if else's, in another nested switch cases. What happens here is that we break some of the solid principles. We break the single responsibility principle, and this is not because this method is not doing one thing. It's doing one thing, it's quoting you. But it doesn't have only one reason to change. This is what Uncle Bob said, right? So the single responsibility principle is often mistaken that one method should do one thing. And one thing can be lots of things that you can imagine, right? So you should look it from a helicopter view and say, is there only one reason to change for that method? No, hell no. You can change that method for hundreds of reasons. So it breaks this principle. The other principle that it breaks is my favorite one, the open close principle. Yeah, when people say solid, they usually say S, and then the other mnemonic, part of the mnemonic is somehow omitted. And they only say, okay, it breaks solid because it breaks single responsibility. If other principle is broken, probably it doesn't break solid, right? But there are 4 more or 5 more, AOID, yeah. So 4 more principles that could be broken. And open closed is the second biggest principle that's broken inside any code base. The first one is the single responsibility. And what says the open close principle? Why this clicker doesn't work? So in this case, any new rule that adds, it can be any new class, like second class if you have not only first. It can be for retired people class. Everything that comes from the back office tool should be implemented by the developer inside this code base. Go to an existing class and add new rules. This is breaking the open close principle, which says that any code base should be open for extension. It can be extended as much as you want, new features, but it should be closed for modification. So you wrote one method, and this method probably should never change for adding new things. If the business logic is changed, probably it can be changed. You extend your code base, you should not touch the existing methods. Any touching of any existing method is a severe violation of this principle. And people in my company know that I may break their hands or legs or something if they do it. Yeah. And the other principle is also violated. Here is the last one, the dependency inversion principle. There is no abstraction used here, and of course, other thing that's not happening. All the concrete low level logic is in this higher level module. You cannot reuse it anywhere else. You don't know which module to which depends on. So a couple of violations happen here, and all these violations are very common to most of the code bases. So if you have some experience already, you might have seen lots of code bases that are violating at least these three things, and probably many more. So how do we address all of these things? Well, you see the cases of the switch. They can be a design pattern that's called strategy pattern. You may have heard of it, but this is this pattern comes from something that's called replace conditionals with polymorphism. So each of your conditionals can be replaced with a polymorphic solution. You can have a single interface that's doing some logic upon any given parameters, and this logic can be inherited by lots of other implementers. You can now add new implementers as new classes, add them into your class path without modifying a single big switch case. So this is, if you don't remember anything else from this presentation, just remember this one thing, and it is replace your conditionals with polymorphism. It can be any other pattern that is polymorphic, but strategy pattern should be the correct one for this way. Inside any of these strategies, the business class strategy, the first class strategy, the economy class strategy, name it, you want fourth, fifth strategy, there are a couple of new things there, right? A couple of conditionals. And they can be a chain of responsibility because it's not only one thing that's going to be executed. You know, if it's an else if, then it's only one thing. But if there are independent ifs, they can be executed each of them. So you can name it again strategy, but it's not the correct way to name it. It's a chain of responsibility. One of these responsible solutions makes some logic, then passes to the other one in the chain. If you have used Spring Framework, you may already have seen that, which is the filter chain. And it's not only in Spring, it's actually in the servlet engine. So a filter that's executed before any servlet can pass to the next filter by a chain of responsibility. And this can be the same here. Any of these conditionals can pass to the others if necessary. And of course, there are some other things that can be implemented here, which is some kind of a decorator for one rule to decorate with the other rule, which if you're already accustomed to Spring Framework and to JPA repositories, you may have seen that the JPA repositories can accept the so-called specification for querying, and this is a pattern called specification. We can also implement that one. But you will say, Ivan, you are crazy. What's happening there? Specification, decorator, strategy, if-else, switch case. What's happening here? And I will be more than glad to show you. So let's scrap all these cases and say, hey, any of these cases can be actually a strategy. A business fight strategy. It can be, did I click 2 times? Okay. Yeah, good. 1 click only, please. Yeah, please, clicker, work. So another one, economy flight strategy. It can be first class flight strategy. Any of these can be new classes that implement a single interface that's called price strategy. And it will have only one method for now, not in reality, you'll see later. But the method here that is that will do the job will be the calculate price. It will calculate you the price for business class or for economy class. It can have these if-elses wrapped there, but it can be even more abstracted. But at least we should start from somewhere. So we start for extracting each of the bodies of the switch case into different classes, starting to extract the conditionals into a polymorphic solution. And now you can see that in some imaginary map that's called price strategies, how this map works, we'll show you later. We get the strategy by its name. In a typical strategy pattern, there are two methods: supports and the method that is doing the job. So you probably go from a list of different strategies and tell them, hey, do you support this solution? But now we can get it by name, because each of these strategies can have its own name for business, economy, or other class. In a typical solution, it could be a list that is probed. But here we can optimize the linear complexity to constant complexity, which is even better. And now inside each strategy and outside the strategies, we also had some rules that will happen, and we will call them rules, which can be applied one after another in a chain of responsibility. This is the duration rule, which says, okay, whether this flight will take longer than 10 hours, then we will discount your price and return you the new price. It can be if you have more than 3 passengers, then maybe we can discount you as well. These two rules work in conjunction, so you first discount the first one, then you discount the other one. Later, maybe you have the question, which one first? Because if you discount first by 50% and then by 10%, it's different than the vice versa, right? The division is very different thing than the multiplication, sometimes when it's by fractions. But we will see this later. So how do we do that? Well, in any of our previous strategies, we can now have this imaginary list of rules. Before we had map of strategies, because this map we will get single strategy, and this is the correct way to implement a strategy pattern, to execute only one. But for the rule engine, where we have a chain responsibility, we need more than one rule to be executed. So we keep them in a list and execute them sequentially. If these rules, of course, support it, but we will imagine that now in the business-wide strategy, we only injected the rules that are common for the business-wide strategy. These two rules were common for this for the business-wide, for the business class, so we can execute them in sequence. For the first one, then the second one. When you apply the first one, it will return you the new price, and the new price will be passed here. We will use the reduce method from the stream API, which will be the same if we did this with a for loop. If we did it for the for loop with a mutating variable, we can have the price that first equals to 0, then it will equal to what the first rule will give us, and then it will be equal to what the second rule give us by providing the already calculated price. The reduce monad, or it's not monad at all, but the reduce method in the stream API is very convenient to do this job. And now let's get back to this list. How we may have this list of calculation rules injected inside the business flight strategy class. Well, if we have to do this manually, it would be hell. You know, this code can be nested in a lot of objects, and then we need to maintain a whole lot of an object graph. But that's what Spring does for us. And this, the other maybe questionable thing is this price strategy map. What's that map? Well, that map is just a map of string, which string is the name of the class, business, economy, first, second, retired, whatever. So if we go to this business flight strategy and we annotate this class with component, what will happen is that Spring Framework will put it in this object graph, the so-called container, and the inversion of control container will have this object already instantiated. And it also be associated with the name that's written inside the braces. So this is visible, yeah, it's visible. So this business string, uppercase, is something that Spring will inject as a key inside the map here. If you have a map of a string and some interface, what Spring will do for you is to inject you all implementations of an interface in that map as values, and on the left-hand side as keys, you will receive the bean name. The bean name, if it's not redefined, is the name of the class with the first letter lowercase, the so-called camel case. But you can redefine that by several ways. Inside the component annotation is one of the ways to do so. So this is something that you have as a given. And it's something that most of the people actually miss. They don't do it. They only do one interface, one implementation. That's it, we inject the interface. At some point, people start questioning if you have one interface, one implementation, why don't we scrap the interface? Let's inject already classes, and then you have a screwed code base. So think about it. You can use this kind of abstraction here. So let's get back to these rules here and see how we can optimize it even more. Because now we introduced strategies, now we introduced some rules, but we need to manually inject the rules that are bound to this particular strategy. Can we do it in a way that each of these things can be extracted in some rule engine and be executed in a sequence? Because there are a couple of things that should happen here. So how do we see that? In the list of rule that you saw before, or the imaginary list of any rule that we may have, we should group them. Each of these rules can be a part of a group, and I will show you later why. Because you have a group of rules, if I go back, a group of rules, let's say for the business class, that they should be executed on their own only. These things that are in else if, only one of them should be executed. So it's all the ifs and else ifs are one group. But the things that are separate ifs are different groups. So what we do is having all the else ifs as different rules inside one group. The other else ifs, the other group of else ifs in another group. I clicked a lot of times. So each group also have its own order, because the groups should be executed also in order. First, the first if else, if else, if else, then the other if else, else, if else, if else, if else, if. And then we execute the group sequentially. The first group, execute the first group. On the first group, find the rule that needs to be executed and execute only it. Because we have else ifs in any of the groups, it means that only one condition will be evaluated. So only one rule per group shall be executed. And this whole code base behind can be rewritten to a rule engine where you have groups and rules, nothing more. And let's try to explain it before implementing it. So this is the first group. The if, else if, else if is group 1. And the first if of these else ifs is rule number 1. In the same group, you have rule number 2. And in the same group, you have rule number 3. So this is one group with 3 rules. Then we pass down and we have group number 2 with rule number 1. No more rules in this group, but it's fine. Group one rule and one group, it's also fine for single ifs. Then we go further for the next type with group number 3, which has only rule number 1. Since these two ifs are separate and can be evaluated simultaneously, they are different groups. So group number 4 with rule number 1. But then we go to the economy class where we have else ifs. So how many groups and how many rules? 1 group, 2 rules. Exactly. Thank you. So yep, this will be group number 5 with rule number 1, and the else if will be rule number 2. And since this rectangle hides some other groups, there is also a if with 3 else ifs. So how many groups and rules? 1 group, 3 rules. Congratulations, congratulations. 6 group with 3 rules. Yeah, so you already know what I'm going to show you, right? What I'm going to show you is actually an interface called discount strategy now, but it has 4 methods. It has the grouping priority, the inner priority of any of the rules, whether it supports this condition or not, and then if it supports it, to apply the discount. So we can now, for each, all the rules and apply only the applicable ones. Let's see this with some implementations of the discount strategy. So we have the business discount strategy, which is, let's say, a parent discount strategy. It's not going to be executed by itself. It will be inherited by other discount strategies. Only thing is that it adds a supporting rule. So the supporting rule says, okay, your type of the pricing should be business, and you can add more conditions into that. So one inheritance of the business discount strategy can be the duration discount strategy, which will have the grouping priority of 10. So you say, why 10? You're crazy. How do you start with 10? Yeah, I can tell you. This is because you need to have some buffer. I told you, your code base should not be touchable, right? You should introduce new rules, and you should not touch your existing one. So give some buffer. You may want to inject something in between. If it's 1, 2, 3, 4, 5, what do you do? Maybe doubles. So 1.1, 1.2. So you need to have some buffer. For real numbers, you know, there are infinite numbers between 2 real numbers. But for integers, you need to have some buffer. And this duration discount strategy supports that not only because this is a business class strategy, but because the duration is also satisfied. If you see that in, let's say, 10 hours discount strategy, which is kind of a duration, it says, okay, my parent should support it, and my parent says, I'm a business class. But I also, with the AND operator, I say, and the duration should be more than 10 hours. So this class will return true, this object will return true only if it's business class and the duration is more than 10 hours. So this concrete rule will be violated only by this condition. And it will apply the discount by 20%. If we go further, for the persons discount strategy, it's again a business discount strategy. And for more than 3 persons, we will have the same thing. My parent should support it, and the person should be more than 3. So it should be business class and more than 3 people. Otherwise, the other thing is to calculate the price. That's the easy part. Now you say, okay, I have all these rules inside my code base. What do I do them? What happens with these priorities? 10 priority here for the groups, 50 priority here for the inner priority. How do I use that? No, you need a wrapping object that will inject all of these as, let's say, a list and group them by groups, and inside the group, order them by the priority. So it may look like something like that, which goes to the list of discount strategies. You inject in your constructor a list of discount strategies. That's normal. Your Spring framework will give you all components, all beans of type discount strategy as a list in your constructor. That's happening as a given. You have 10 implementations. All of them are annotated by component, service, name it, any stereotype annotation that creates a bean. Then all the beans from a certain type can be injected not only by map, as I shown you before, but as a list as well. So you inject them as a list, and you need to produce a list of lists. So a group with its own rules there. The first thing you need to do is to sort the things by the groups. So you have group with priority 10, and all things that are sorted by 10 should be the first things. Then group with priority 20 will be the next rules. And inside that, you need to apply a different sorting, which will be for the inner priority. In the group of priority 10, you need to sort by its own priority, which will be again 10, 20, 30, whatever it is. So if you put a breakpoint here inside this constructor and invoke your program during the runtime, before you send any request, because this constructor will be evaluated during Spring is trying to inject your beans, you can see in the debugger this one. You can see all the 5 groups of the things that you saw in the previous slide. You saw G1, G2, G3 to G5, right? These are the 5 groups. And each of these groups have several rules. The first has 3 rules. Some of the others have 2 rules, another has 3 rules again, and so on and so forth. These ones that are with 1 rule only, I haven't expanded them. But you can easily see that. So first, we will ask whether it's a 10 hours discount strategy, which is a business class discount strategy. So it will ask first the rule, are you a business class, and is there a duration more than 10 hours? If it's not business class or not 10 hours, then it's not going to be evaluated. So if it's, let's say, economy class, all the things for business class, all these 3 rules will be skipped. But then they will be asked, of course. You ask this one, this one, this one. Then you ask whether they are more than 10 people for the other economy class, and so on. So you guess it. The other things will be asked as well, whether they support it. So let's get back to this code here. Maybe it's again like the reduce before and the reduce now. Maybe again, some people will say, what kind of shit is that? Okay, this one is this one. You start with one price, you go from all groups. For each group, you go for any strategy inside the group. If the strategy supports, then you execute the strategy and break and go to the next group. So only 1 rule per group, right? You for each the rules inside the group, but you only execute the first one that satisfies the condition. The others are skipped by the break keyword. So that's it. That's the same as this one. That's the functional approach. That's the traditional approach, which I really don't like, but I know people are accustomed to this one, so let me show it by that way. And now, since we have this discount strategy executor, which can which have the strategies inside this matrix of strategies, and can execute them by disorder, because it can do this one. It can for each them and execute the strategy that's necessary. We can just now inject in this code base, which we were custom before because we had this code base. In this code base, where we took the initial amount, we can inject the executor, and what we can do afterwards? We can just say apply discount. Now, all the strategies will be iterated, asked whether they support the condition, and be applied if they support the condition. So in the end of the day, when you say, okay, let me return the quote, then you receive the same price that you received with all the switch case now. So you say, okay, Ivan, but you've hidden the same if else's inside what were 12 classes. Yes, I did. But what I did also is that now you can easily add a new rule. You can just create new class, implement the interface, add the priority, add the supports method, and then this method here that's called quote, this one, will remain unchanged. And that's your goal. This to be remained unchanged. You don't need to support your engine code. You need to support your business logic only. Imagine your team needs to implement hundreds of different rules. They don't need to go to one big switch case and all of them add new ifs. You never merge that. Never. It's not possible. But if they create new classes, it's possible. If this is a compiled jar and you just need to refer in the class path a new compiled class, it's also going to work. Compile a new class, add it inside the lib folder, restart the application. Works like a charm. You can add new strategies and new rules from outside. You don't need to add them in the same code base. It can be libraries, assembly plugins in Maven, you name it. So now we have a completely extensible code base that follows the open-close principle and the dependency inversion, because now we rely on the abstraction called this called executor, and also importantly, the single responsibility principle. Now this method has only one reason to change, and any of the other methods too. So if our way to apply discounts changed in a way that it needs a change here, yeah, this will be the reason. But otherwise, adding new strategy, adding new rule, or changing the rule from 10 hours to 12 hours wouldn't need to change this method. This method gives you the quote, not to calculate some hours from 10 to 12. And this is the thing that's very beautiful in the inversion of control framework. You can just receive these things as lists and maps and create such engine which is so decoupled, and Java is so beautiful a language where you can just load some things in the class path, because you just say when you run your jar or class file, you say, what is my class path? -cp or -class path, right? And you say this jar, this class file, so you can just add new classes. You don't need to compile a whole code base to add a new class. You need to compile only one. It can be external. And that's a real beauty. So, guys and girls, ladies and gentlemen, remember, you can inject the beans not only as they're in a single implementation, but as a list from the parent type, any of the parent types. It can be a big chain of parents, or as a map of a string and the parent type. And the key for the map can be controlled. It has default naming, but you can control it, and it can be in your favor. You can do it by using any of the stereotype annotations. Component, service, if you use the bean factory method, you can even add more names. One strategy might be associated to 10 different names, and you can still inject it as one of these names. So it's also real beauty that Spring and the other inversion of control frameworks give us this opportunity. Of course, if you had one-shot solution for a decorator pattern, if you want one thing to inject itself the other thing and execute its parent and itself, you can create easily a decorator with primary. The primary annotation will just say, okay, I have two implementations of one interface. I want to inject the interface, not the list. But I have two implementations. Which one Spring should use? If you annotate one of it with primary, it's going to work. But it's a one-shot solution. If third one comes, you need to change the primary. So spare to use that unless you're pretty sure what you're doing. The other thing is that I haven't shown it, but you can create beans conditionally. Some beans may not be loaded at all. You can have a configuration which can use some if. Let's say, if our environment is production, if we have this feature flag enabled, if we are in jurisdiction like United States, maybe we can apply less discounts because we can pay these guys. Or if we are in Bulgaria, more discounts, people cannot pay that much, probably. So you can have a lot of ifs to do that, but not only ifs, because ifs can be evil. You can have conditional on missing bean, conditional on property, and conditional on anything else. There are 10 annotations that start with conditional on. So your beans may not be even loaded in the inversion of control framework if they do not satisfy some condition. So this is also something very useful for you. Some of your beans in one deployment to be there and in another deployment to not be there. And don't violate the open close principle. I'm breaking hands and legs for that. Please, 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 please. Okay. Thank you very much. Okay, my name is Ivan Yonkov. You can find me on LinkedIn or follow our company in the social network. If you have any questions, I see you don't have, so enjoy your after lunch, yeah?